So this is also, there's not like a lot of like details. Most of it is like probably a lot of stuff that you know. So when it comes to climate, right, we're talking about different kinds of things, right? So we talk about precipitation, which is like the amount of rainfall, or basically like how much waterfall or snow and all that kind of stuff together. That's all called precipitation, right? So climate is determined by a lot of different things. So
Wait. What is brother? Precipitation is just rain, right?
yeah, it's rain. I think snow and all those kinds of things, they also
Yeah,
count.
all those like things that fall from the sky, brother.
Right. So
The
precipitation,
different weather.
counts. Sorry, precipitation is one aspect of climate, right? You have temperature, humidity, all those kinds of things, right, are climate, and that can be affected by a lot of different things. So we have altitude, which is like how high something is. We have latitude. So we're going to talk about some of these things like latitude and those kinds of things. All right. So does anyone know what is altitude? What is Yusuf? What is altitude?
Altitude is like the height, or like the elevation
Right.
of any one specified object or
Mhm.
thing, like like the altitude of a plane.
Right. So how do we measure altitude? Like if you have the top of a mountain and you say, oh, this is 2,000 feet high.
Mhm.
Uh, that's 2,000 feet from where exactly? How do we measure? How do you measure altitude?
From ground level where the sea is, I believe,
From
right?
the sea,
Sea
right? So
level.
sea
Yeah.
level, right? Exactly, right. So they call that sea level. So wherever that sea level is, wherever the level of the water is, from there it's 2,000, right? Um,
Yeah.
all right, good. So we have latitude also. All right, Anas, do you know what is latitude? Anas, do you know what is latitude?
Say, honest.
All right, Anas here. All right. So latitude
But
is
I think
basically.
they came rid of.
All right, good. All right. So latitude is basically. So if we take a look at the Earth, right? We can divide it up into kind of like this grid, right? So at the very top, you have the North Pole. At the very bottom, you have the South Pole, right? And in the middle, you have the equator. So basically, the lines of latitude, you see these lines going in like circles around the Earth, right? So we're following each of these circles around the Earth.
Mhm.
Each of these is a line of latitude. So the latitude, right? You notice like anything, this circle right over here, right? Let's take a look at the circle at the top, right? Basically, its distance from the North Pole at every point on this circle, right, is basically the same, right?
Mhm.
So every each this line right here, every point on there is basically going to have kind of like the same kind of climate, right? There are obviously like going to be differences and that kind of thing, but like overall, kind of like its temperature range and stuff is going to be kind of strongly determined by which of these circles it's on, right? So something that's located on this circle somewhere, right? That's going to be like very cold. Something down here, something along this line of latitude, anywhere that it is, in general, is going to be pretty warm, right? There's going to be other differences, right? Differences from local weather patterns and those kinds of things going to cause some differences. But basically, you see how the latitude strongly tells you, like, is the temperature going to be cold or is it going to be warm? What is going to be the climate there, right? Strongly determined by this line of latitude. So, for example, high latitudes are going to be near the poles, right? So this one right over here is going to be a higher number degrees compared to near the equator. So near the equator is like 0 degrees, and so so near the equator it's
Mhm.
0 degrees, and then
But
as you move
brother,
closer to the yeah.
uh, so the latitude works like not from bottom to top or top to bottom. It's like the center is the highest latitude, and then it goes smaller at each side, right? On either side. Till the
uh,
polar axis is right. The
Kind of
polar
so, right.
axis.
So you see the poles have the highest latitude,
Well, they have the highest
right?
latitude.
They have the
And the
highest
center has the lowest.
Right, the center near the equator, right, has the lowest.
Yeah, near the equator.
Right. So basically, you would say high latitudes are colder,
Mm-hmm.
low latitudes are warmer. Does that make
Mm-hmm.
sense?
Yeah.
So for example, you have zero. So at the equator, you would say it's 0 degrees, right?
Mm-hmm.
The latitude is 0 degrees. And then at the North Pole, so basically, as you go from the equator to the North Pole, the numbers go up, like 0, 1, 2, 3, all the way to 90 degrees north, right? So from 0 at the equator, like 10, 20, 30, 40, 50, all the
40,
way to
50.
90 degrees north. And then it's same thing on the south side, except you would say instead of like, for example, like 45 degrees north, you would say like 45 degrees south.
Mm-hmm.
That makes sense, right?
Yeah.
So you start from 0 at the equator. So those numbers near the equator are low numbers, right? You would say low latitude.
Yeah.
Near the equator, it's like, I mean, near the poles, it's like higher numbers, closer to 90,
Yeah.
right? So we have latitude and sunlight, right? So if you take a look at this picture over here, it kind of tells you the same thing. You see the equator is at 0 degrees, right? And as you count up higher and higher, you have higher numbers and then north, like 60 degrees north. Here you have 60 degrees south, right? So the higher numbers are higher, are colder. The lower numbers are near the equator, so they're going to be warmer, right?
Mm-hmm.
So you see this line 30 degrees north, right? Does anyone know what
Yeah.
is the name of this line 30 degrees north?
The tropicals. Oh, sorry, the temperate zone, brother.
I'm just talking about this line, just one line, 30 degrees north. You see this dotted line? There's a name for this line.
The Tropic of something. I'm not sure
Yeah,
which
Tropic
tropic,
of
brother,
something.
right?
Yeah. So
Tropic of Capricorn?
So I think it's Tropic of Cancer in the north.
Oh, okay. The top
Sure,
one is
sure.
Cancer, the bottom is Capricorn.
Yeah. To make sure. So I believe so. I think Cancer is. Just a second. Yeah. So in the north, right, 30 degrees. That's Tropic of Cancer. In the south, it's
alright.
called Tropic of
Capricorn.
Capricorn, right? So between these is generally considered to be like a tropical area, tropical climate,
Yeah.
right? Now where we live, so we live kind of right on the edge of the tropics. So, but
Yeah.
basically most of North America up here, most of the United States is like in the temperate zone.
Mm-hmm.
So the temperate zone is called temperate because temperate means like not too much.
That's
So-
like it's like
Yeah, it's
like
not
moderate kind of thing, right?
right. So it's like this is kind of like where most civilizations have existed. Like most of the powerful civilizations, right? They usually start in the temperate zone because that's like a good place. You know, in the tropical zone, right? People historically they spend a lot of time just trying to stay cool. You know, their food rots quickly. You know, all that
Yeah.
kind of stuff, right?
Farming is harder, I guess,
Right.
a little bit.
Farming has always been a lot harder. So in the temperate zone, that's where like wheat was discovered. All this kind of stuff. Most of the farming and good stuff, powerful. Not always. There are always exceptions, but like generally throughout history, like in the temperate zone, that's where it's just easier to live, right?
Mm-hmm.
It's easier to store, your crops. You know, you can keep your crops dry, and they're not going to rot quickly. In the tropical zone, you can't store food for like very long. So different kinds of theories people have as to why, like most of the powerful kingdoms and stuff are usually in the temperate zone.
Mm-hmm.
All right. So it says Earth is not a perfect sphere, but an oblate spheroid. So what does that mean? Right. So what it means is that Earth is not actually a perfect sphere. Right.
Mhm.
So let's say we go from the center of the Earth. Right. We take the center of the Earth, and from there we head up to the North Pole. Right.
Mm-hmm.
That would, if in a perfect sphere, we would call that the radius. Right.
Mm-hmm.
That distance in a perfect sphere should be the same as from the very center to the equator, right?
Mm-hmm.
You see how in the sphere, those two distances should be like perfectly the same, right?
Yeah.
But in the Earth, it's like slightly different. It's not like too much different. But you notice right over here, right? Here's the center of the Earth. Up to the North Pole, that distance is a little bit shorter than from the center of the Earth to the equator. So at the equator, it's kind of like bulged out a little bit,
Mm-hmm.
right? So you can see it's not too much, right? If you compare the numbers, it was like 6,378,000 This one here is 6,356,000.
356,000.
Right? So it's not like a huge amount, but it's just like a slight amount. Right?
Mm-hmm.
Right. So it basically it bulges. Let's say Earth bulges slightly at its equator due to the momentum of its rotation. What does that mean? Like due to the momentum of its rotation? Like why is this happening?
I mean, it's rotating, but I'm not sure why that rotation is causing it to
Right.
bulge.
Right. So Earth is like spinning, right? Like once per day it spins around, right? So, I mean, like let's suppose you have a, you know, some kind of like bowl, right? And there's like some like piece of Cheerios in it or something, right? So you take the bowl and kind of rotate it in a circular motion.
Uh-huh.
What's gonna happen? What's gonna happen to the stuff in the bowl?
It's gonna start flying around, brother.
It's gonna start to like basically kind of like almost like head out. It's gonna look like it's heading outside, right?
Yeah, I know what you're saying. Like it's gonna start like if you put your hand in water and you start spinning it, then everything, all the water like goes to the outside ends
Right.
of the
It hits the
bowl.
sides, right? So this is the
Yeah,
same
like a
kind
tornado
of
kind of
yes. This is the same kind of principle, right? So the
Alright.
mass in the Earth, right, as it's spinning, right, it kind of pushes on the outside, so the equator kind of bulges out a little bit and becomes a little bit bigger, right? So this is the Earth's, shape. All right. All right. So I think most of this we talked about, right? The tropics, temperate zone, and then at the top, polar zone, right? So the polar zone is obviously very, very cold. So there, you could like probably preserve a lot of food, but you're not gonna be able to grow the food, right? So the temperate zone is kind of like, kind of like a mix of both, of the tropical and the polar zone. It's a good climate for growing things, but it's like cold enough, it's like dry enough, to where you can still store food for a long period of time. In the polar zone, right, you can store food, but there's nothing to grow, right? You have to actually just catch, animals and stuff like that. All right. All right, so we have altitude. So we talked a little bit about altitude. Altitude is the elevation from the sea level, right? So as you go colder, as you go higher up, then then the atmosphere is colder than down below, right? That's why you see like snow on the top of mountain peaks and that kind of thing. So if you're in an area where it's very elevated, then in general it's just kind of going to be a little bit colder than you would expect at that latitude, right? Like even if you're near the tropics, right? If you're high up, it's going to be colder than you would expect at the tropics. Does that make sense? All right. So it says altitude can affect temperature and humidity, right? So humidity is basically, so what is humidity?
Humidity is like the amount of basically water vapor in the air, I guess you could say.
Right, so basically
Like moisture, the
yeah.
amount of moisture in the air.
Right, so basically like the amount of moisture that's in the air, right? So for instance, warm, moist air can cool as it rises up a mountain slope. So basically, on one, let's suppose you're, near the ocean. All right, okay, let's suppose there's a mountain range, right? And on one side, right, there's the ocean. And on the other side, right, there's not the ocean, right? So this is the case in, like, for example, California, right? There's a lot of mountains. So what happens is that, from the ocean, right, there's a lot of, like, moist air coming, right? Because the ocean, right, evaporates and there's a lot of water in the air there. But as that air rises over the mountains, right, it basically cools. And so, right, what happens when it cools, right, all the water comes out of the air. You get rain or snow. Like, for example, when it gets cold in the morning, right, what do you see when you go outside?
You see a lot of like dew, or sorry, you see a lot of fog and stuff, dew on
exactly,
the
right?
leaves and
Fog, dew, right? Even though there's no rain, there's still water all over the grass, right?
stuff.
Because it's cooled down such that the air cannot hold all that water. So what happens is on one side of the mountain you get like a lot of rain. Right? Does that make sense? Have you heard like on one side of the mountain you get a lot of rain? All the rain, all the moisture is let go from that air. And then when the air passes through on the other side, it becomes very dry. That's why in California, like one side of the mountains, on the left side near the Pacific Ocean, there's a lot of rain. On the other side, there's a lot, almost like a desert, right?
Yeah.
because all that
The
air
snow
passes over the mountains, lets go of all its moisture. There's no more moisture to get to the other side when it gets to the other side. Does that make sense?
Yeah.
All right. So globally, there's a lot of different kinds of weather patterns. So when we talk about weather, right? If you have the weather of an area, right? There's two things that affect it. Right? One is kind of like global weather patterns, right? And then the other thing is like more like local weather patterns, right? So globally, there are certain kinds of patterns in terms of how the winds move, how the air moves in certain areas. So for example, right here, it's showing you that between the equator, right, between the equator and 30 degrees north, right, you have these things called northeast trade winds. So basically, the tendency is, without other factors, the tendency is for air to move in the direction that the arrows is moving. Does that make sense? Now,
The northeast is
right. So basically, it comes out of the
northeast is opposite to that direction, brother. It's going the wrong way.
No. So they call it by where it's coming from.
Oh,
So,
okay.
so if you're standing here and say, "Oh, the winds are coming from the northeast," does that make sense? So this picture is showing you like in certain areas, they're kind of like typical weather. They're typical wind patterns. Now that doesn't mean that everywhere that this is how the wind blows, because it's also affected by local weather patterns and stuff like that.
It's like typical global wind patterns.
Right. This is the typical global wind patterns. So this is the typical global wind patterns, right? And then this shows you where the air rises. So along with these wind patterns, there's also so this is like more like you could say kind of like horizontally, right?
Yeah.
But then vertically,
That's the Coriolis effect that it's showing, right, brother?
Right. Correct. So we're gonna talk about the Coriolis effect in just a second. So in addition to how it moves, in which direction, north, south, east, west, we also have up and down, right? Like basically kind of like going into the earth and out of the earth. So these cells on the outside, you see these like squarish kind of cells on the outside. That shows you the typical patterns, more like up and down. Right? So for example, what it's showing is that near the equator, right? What happens to the wind? What happens to the air? Is the air generally rising or falling in that area?
Wait, what'd you say, brother?
So near the equator, right? Is the air there generally rising or falling?
Falling.
So in those areas is generally,
Because as the air falls, it becomes warmer, right? Or as it rises, as it rises, it becomes warmer.
so here I think is falling.
No, but as it goes higher into the air, the colder it gets, right?
Right. Wait, hold on. I think this is showing you like different things. All right, hold on. Let me see if there's another picture. Yeah, let me see if there's another picture that I can bring. Okay, yeah, I think this should look. Yeah, I think that picture is a little confusing. All right. All right. Do you see this picture over here?
No.
No, okay, let me see. I'm trying like a new share.
Oh yeah, I can see it now.
Yeah, okay. All right. So this over here, so we talked about, you see in the blue and the red, on the globe, right? We just talked about those, right? Like this one right here is called the northeasterly because it's coming from the northeast. Remember that? Right. So this is typical. This is typical between equator and 30 degrees north. Now another thing is, so this is like north, south, east, west movement of winds. Another thing is you see these things called Hadley cells, Faro cells, polar cells. This shows you typically how the air is moving up and down at these locations. So notice at the equator that the air is moving up, right? Like if you're standing at the equator, generally the warm air is rising,
Okay,
Does that,
yeah.
does that make sense, right?
But as it rises, it gets cooler, right,
Exactly.
brother?
That's what you see when it rises, then it starts to turn blue, right?
And then it passes on or
Then it
something
goes
like that,
back
right?
down over here. Does that make sense? Right. So these cells over here, right? So you see how like the what the arrows that are on the Earth, and these
Uh,
circular cells, they're like basically kind of like in different dimensions, right?
mm,
Right. Like these ones here on the globe, this is like like if you point north, south, east, west direction, right? If you're standing and you say, oh,
mm,
you have north, south, east, west, right? Notice we're not when we're doing that, we're not pointing up or down, right? There's nothing to do with up or down.
uh,
Does that make sense, right? So the up and down part, that has to do with these cells on the outside. Is that gonna make sense? All right. Any questions about how this works?
so those outside hold up.
Hmm.
So those outside rings that you were showing is that the Coriolis effect or whatever? Are we gonna talk about that
No,
now?
no. Okay. So let me show you what the Coriolis effect is. All right. So this is the Coriolis effect, right? So what it means is that so what it means is that let's suppose you have something that's moving in the northern hemisphere, right? Now, assuming that it's not moving exactly along the line of latitude,
Uh-huh.
okay, that means that it has some up and down dimension to it, right? What it means is that in
Can
the
you repeat this? Can you? I don't understand.
okay,
Like,
okay. So first of all, let's take this case, right? It means that
uh,
in the north,
uh,
objects that are moving, they tend to travel to the right, right? They're not going to move straight on the earth,
uh,
right? They're going to move to the
to
right,
the right. It's like right, like down
right,
towards the equator.
right. So we'll explain like why. In the south, it's going to be slightly to the left, kind of opposite.
Uh-huh.
Okay, so
Towards the equator once
right.
again.
So here's why. All right. So let's take a look at this picture over here. All right. So let's suppose that
Mm.
you're on a plane flight from the North Pole to right here on the equator. Does that make sense?
Uh-huh.
So you're flying. All right.
Uh-huh.
So now if the Earth stood still, well, you just fly from here straight here.
Mm-hmm.
But notice what happens when you fly.
Mm.
The Earth below
The
you
Earth
is
is
not.
rotating.
The Earth is moving, right?
Uh-huh.
So if you just try to fly straight down, you're actually going
Uh-huh.
to end up over here, slightly over here, over here.
Yeah, because you're gonna keep deviating off.
You can keep deviating, right? So like,
Uh-huh.
right? So if you're right, you start here, but as you go down, right, like Europe has moved over here to the right. So now
Uh-huh.
really you're over here somewhere. And
Uh-huh.
as you go down, like you'd say, oh, I'm just going to go down to where Africa was, but Africa has now moved even more over here.
Uh.
So you see how you're slightly move over here to the right, like this.
Oh, so like so it depends on the axis of rotation of the
Right.
Earth. So
But
since
for
the
example,
Earth rotates.
let's suppose I'm here, and let's suppose I just want to move like straight to the right, along
Uh-huh.
the line of latitude. Am I going to start moving to the right here, or start moving to the right here down like this?
Uh, wait, what?
So let's suppose now I'm moving like just straight to the right. I have no
Uh-huh.
I have no up and down dimension to my movement. From
Uh-huh.
here, I'm just staying along this line of latitude, just straight to the right. From left, I'm just going to the right. Now,
No, you wouldn't move. You wouldn't move straight to the right because the Earth's axis also has a tilt to it. So that means you would kind of like,
right?
since it has a tilt,
No.
you'd kind of move like this. You know what I'm saying?
Right. No. But this picture is correcting for you. See, in this picture, we're looking at it such that there's no tilt. The North
Oh,
Pole
okay,
is
there's
straight
no
at the
tilt or
top.
nothing, like no non-rotating Earth.
Right.
All right.
So basically,
Yeah, then you would move. You would move straight. Yeah.
yeah, we went straight, right? So this Coriolis effect, it happens when there's some up and down, dimension to your movement. Okay.
But brother, if the Earth is tilted and you're moving left to right, then you would also experience. Because look in the picture that you showed before.
But when the Earth is tilted, right?
Mhm.
Like, what does that mean? It's spinning along its tilt, along the north.
Oh yeah. Never mind. I get it now.
Yeah.
But why are those pictures of the Like, why is the picture before showing that it's moving across? This is the equator that it's showing, but
You're talking about
you see what I'm saying? Like, you see what I'm saying?
you're
Like
talking about the difference between this picture and this picture.
no, I'm talking about the previous,
This one.
the other picture, the one to the left. Yeah, this one. So you see how it's like showing that they're moving towards the equator, even though they're moving right and left. They're not moving up and down. They're just moving right and left,
Yeah.
but they're still moving
Yeah.
like
So I think
towards the equator.
I think this one is kind of moving like slightly diagonally. Maybe there's like a little bit of
Oh,
dimension.
okay.
Maybe there's like a little bit of up and down dimension. Yeah. So if
Uh,
this was moving exactly to the right, like if this was at 30 degree, if this was at 60 degrees north latitude, right,
uh,
and it was just
uh,
staying at exactly 60 degrees north, then
uh,
it wouldn't suddenly like start moving to the right. So this is
uh,
assuming that it's kind of like moving like slightly diagonally, and that's why there is some like up and down dimension, right? If it's diagonal, then there is some
uh,
like down dimension to it.
uh,
I think that's what this one is showing.
I see.
But I think yeah. So I think this picture is. I see what you're saying. It looks like it's moving to the right. So you're wondering why is it curving?
Yeah, exactly.
Yeah. No. So I think yeah. So I think this is probably not the best picture. I think this picture is a clear explanation.
Yeah, it makes more sense to look at that picture then.
All right. So let's go to. All right. So what else we talked about? All right. So we talked about those different currents. We have the Coriolis effect, and of course, right, we have smaller, local patterns, right? So one of the things
Uh,
to talk about here is called the sea breeze and the land breeze, right? So basically, this pattern right here manifests itself locally, kind of like every day, right? So let's suppose here's the daytime, all right? So during the daytime, so here's the principle here. The principle is that the water, right,
can
basically
hold heat
doesn't.
longer, right?
What happened?
The water basically holds heat longer or something like that, or it
Right.
takes
So
longer to absorb
exactly
heat,
right.
right?
So it takes a lot longer for water to change its temperature.
Exactly. But
So
it holds its temperature for longer, right?
correct. Right.
Right.
So
Yeah.
the sun
Uh-huh.
during the day heats up the land like much quicker than the sea. The sea stays cool.
Yeah.
The land becomes
Uh-huh.
warmer, right? So obviously
Uh-huh.
warm air rises. So the warm air is going to rise, and then that's going to give you kind of like a little bit of a vacuum here. So cold
Uh-huh.
air from the sea is going to have to take its place. Does that make sense?
Common, yeah.
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 So this kind of pattern occurs during the day. This is called a day breeze. During the day breeze, this person is going to have this cool kind of sea breeze coming in,
Uh-huh.
right, from the sea to
But
the
that doesn't
land.
necessarily mean that it's gonna be colder in the day and hotter in the night, right?
Right. Yeah.
Like,
Right.
it's not
Yeah.
it's not necessary, right?
Right. This is just like one factor.
Uh
Right. So now at night, right? Remember the land, right? There's nothing to heat the land anymore, so it cools down much
Yeah.
quicker.
much
It's
quicker.
very cool. The sea
Uh-huh.
also starts to turn a little bit cooler, right? But obviously it can take a lot longer, right?
Uh
So in this case, the sea is warmer. So you see how
Uh-huh.
the pattern is going to be reversed. In this
Yeah,
case,
it's reversed now.
in this case, there's going to be a land breeze from the land to the sea.
Uh
Does that make sense?
yeah.
All right. So I think so you just have to So if you understand the principle, then this makes sense. So in the day, you have a cool sea breeze like this. In the
Uh-huh.
in the night, it's like basically reverse. All right.
Uh
Talk about this. All right. So now we're going to talk about like different kinds of biomes. I think you probably guys know most of these already. So there's different kinds of biomes, right? In the water and terrestrial. Terrestrial means like on land, basically. And then
Yeah.
and then you have different kinds of like marine and freshwater kinds of biomes. So you have marine, which is ocean. Marine always means like salt water. Freshwater is like rivers, streams, stuff like that. And the rest of these are terrestrial.
marine is ocean water? Marine
Uh,
is ocean water?
Yeah, marine is ocean.
Alright.
Right. So and then the rest of these four at the bottom, these are
Terrestrial.
terrestrial. Right. So we have abiotic factors. We talked about this last time, right? These are things that are
Non-living.
non-living factors, like temperature, precipitation, topography. What does topography mean?
The land, like the land's, what's it called? The layout of the land, the layout of the
Right.
land's location, its
Right.
altitude, all
Right.
these factors, right?
Right, exactly, right. So that's the topography, like whether there's a mountain or it's just a flat
Yeah.
plain, stuff like that.
Yeah, stuff like that. Yeah.
And it's just saying again, biomes near the equator are usually warmer, and near the north and south poles are colder. So we're gonna look at a little bit at what are the different ones here. So these are some examples of terrestrial biomes. So you have different kinds of grasslands, right? You have like temperate grasslands, right? Where are some examples of where there are temperate grasslands?
Temperate grasslands. Oh, in the temperate zone or whatever, in
Right.
the thing.
Right. So usually, like if you know, like out west, there used to be like what were called the Great Plains, right?
Oh,
Where there were like just buffalo roaming all over the place, right?
yeah,
So
the
those
Wild West
right.
kind of
So those
place.
are like the grasslands of the temperate grasslands.
Those are nice
Also,
for farming,
mhm.
right? Those are like
yeah. So
ideal
yeah,
farming
yeah. So I think most
zones.
of that area is probably taken up by farming now.
Yeah.
So yeah. So the Great Plains, they don't really exist too much anymore, except for like the national parks and that kind of thing. You also
Mm.
have the tropical savanna, very similar, but that's more like like Africa and
Much more
stuff like that.
hot.
Yeah.
Yeah.
So
Much
we
more
see
hot and stuff.
right. If you watch those like videos of like African wildlife and stuff like that, so those are
Yeah,
also grasslands,
zebras
but
and
they're more
stuff.
tropical.
Mm.
And then you have different kinds of deserts where there's low precipitation, right?
Mm.
You have taiga, which is kind of like right underneath tundra. So this is kind of like, I think it's kind of sort of like a mix between the tundra and like the grasslands, I would say. Like this is where,
Yeah, I just searched up a picture.
oh,
It's like the outskirts of Pakistan, but it's like cold grasslands
yeah,
basically.
you could say something like
Cold,
that.
plain, mountainous kind of grasslands.
Right. Yeah, that's where like I think like reindeer and stuff like that sometimes live there.
Yeah, yeah, yeah,
Right.
yeah.
So these are the different
You'll see like rams and stuff in the mountains over there.
right. So these are
That's kind
different
of
types
that's
of
kind of nice.
things. At the bottom it says alpine, right? Alpine means what?
I think alpine is like mountainous, snowy areas, right? Like
Right.
super,
So you
like
notice on
snowy, like tundra, but in the mountains.
right. So you see this like light blue. So notice like in the Rocky Mountains here, in the Andes Mountains here, right?
Yeah,
In the Himalayas, those are alpine, right? That's like very high
yeah,
up.
yeah, yeah, yeah. Yeah, that's what they are. They're like
Right.
mountainous,
Right.
cold areas.
Right. So they're going through. So I think you probably know most of these. So we'll just kind of look at them. So tropical rainforests, right? You have
Mm.
very warm temperatures, a lot of moisture. So it doesn't necessarily mean that it rains every day. I think some people I think when you remember like elementary school, people just say, "What is a rainforest?" or "It rains every day." That's what it means. So it doesn't necessarily
No,
rain every day, but
it's
it's just
very m- moist and kind of like watery and
yeah.
stuff all the
I
time,
think
right?
they classify it based on like what is the number of inches of precipitation per year, something like that.
Exactly.
So it's
Yeah.
not like every day, but it's like if you meet a certain number of inches, then it's like becomes a tropical rainforest.
Mhm.
So the vegetation is very dense, and so like the Amazon rainforest in
Mhm.
Central America, Costa Rica, there's a lot of rainforests. So
Mhm.
it says here that the soil, you would think that the soil is very rich and there's a lot of
Because
nutrients,
of.
right? So
Mhm.
basically, in the rainforest, you see that most of the nutrients are actually now in the vegetation in the because there's so much forest, there's so much plants.
So much vegetation, yeah.
Yeah, so all the nutrients are now basically in there, right?
Mhm.
Um, all right. We have the tundra. Now, the interesting thing about the tundra is we have something called a permafrost. So basically, if you go below, kind of like the surface level, there's an area that is supposed to be that's basically frozen like the whole year. So the upper area, right? If it's hit by the sun and stuff like that,
It
temporarily
melts, right?
like yeah, thaws and then freezes again, thaws, freezes again. But below that, the permafrost is frozen, the entire, year round.
Mhm.
So the top layer, this says partially thaws in the summer, creating bogs and soggy soil. So even then, this is not like very good soil for growing a lot of a lot of things. That's why like roots, they cannot go down too far. You can't have things, you can't grow things that require like an extensive root system. You just have those like like for example in the taiga, tundra, right? You just have those like tiny tiny plants that the reindeer go in
That
and eat and
can
stuff like that.
barely live.
Right, like very small shrubs and that kind of thing.
Mhm.
Right. So that's why they're saying that mosses and lichens are basically the only, basically the main thing that grow there. Just very, very tiny kind of plants that live there.
Hmm.
Most of the animals there have a lot of like blubber and layers of fat, like polar
Yeah.
bears and seals. Right?
Yeah. I've seen real penguin blubber before.
Oh yeah.
Touched it too. It's pretty cool.
I guess people in the past maybe they use blubber for like lighting candles and stuff like that.
Yeah. I think blubber is kind of like fat. It's not fat, but it's like it feels like fat because I remember touching it in second grade. Like our science teacher showed us.
Oh, really? Oh
It feels like fat,
yeah.
basically.
So we have temperate grasslands, right? So in temperate grasslands, they have the soil is rich and fertile due to the constant replenishing of nutrients from decomposing grasses and the lack of rain that would normally leach away nutrients or erode soil. So another thing is that in these grasslands, a lot of these grasslands, they, like human beings have influenced them. So a lot of the grasslands, they're not like 100% natural. Like for example, so they see that, like the Great Plains, right? So the Great Plains is good for farming and that kind of thing for the reasons that they're showing here. One of the things to say is that the Great Plains is actually not they don't believe that that was actually like a natural phenomenon completely. So like the Native Americans, they used to burn huge areas so that grasses could grow there. So like, I guess like naturally that area, they say like probably had like a lot more trees, but because they wanted like the buffalo to be there, they burned like the huge areas and made it into a grassland.
But
So
like it still doesn't change the what's it called, the topography or anything too much, right? Because
right,
you can't
yes,
change the elevation, you can't change like the mountains that are
right,
there.
yeah. So
I
it's
think the only thing that would change is that the trees are gone
right,
and the
yeah,
shrubs and the soil is kind of different now.
yeah, correct.
I
So it's,
I, I th- I think like how the trees are shown in this picture. I think it'd
mhm,
probably be covered with these kind of trees before, but they burned it off, so
right,
just grass now, not
yeah.
too many
So
trees.
it's like a somewhat modification. They modified it like somewhat.
Somewhat
Yeah.
modification, yeah.
So another thing is
I, I would assume you could still plant even without burning the trees, but just not so like large scale and with buffaloes and stuff there.
right. So they say that in the African savanna, the reason that the trees are taken down is usually because of elephants. You see, the major cause of like why
Yeah.
there's a grassland is because the elephants are taking down the trees. So
No.
there's kind of like a balance between like how many elephants there are, how many
How
trees
many
they're
trees
taking
there
down.
are?
So the population of the elephants determines in some area like whether it's going to be more of a grassland or more trees, that kind of thing.
Oh.
Right. So you have temperate deciduous forests. So a lot of these they have softwood and hardwood. There's different kinds of softwood are more like pine trees. Hardwood is probably more like oak trees, maybe mahogany, those kinds of things. So there's all these different kinds
Oh,
of
oak
deciduous.
trees are hardwood?
I think so. They're hard, right?
Mm.
I guess we can look that up, but I think so. So I think pines are supposed to be soft. That's why everybody uses it.
But
I think
hardwood and stuff is used to make was used to make tools like in the prehistoric era, right?
right. So I think even like probably not long ago, but I guess I think most of those because the thing is like so softwood. I think one of the reasons it's
It's
soft is
easily craftable.
it grows so fast.
Yeah.
But in hardwood, the layers of the like whatever the materials that makes the rings, they grow like slowly, like much more compact. So it takes a long time to grow them.
But even like modifying the wood or like cutting it up to make something for bushcrafting or whatever, it's much harder too because it's hardwood, right? It's not
Yeah,
like softwood.
yeah. So I think probably those two reasons is faster to grow softwood. It's easier to work and stuff like that. But I guess
Work with.
yeah. But I guess that's why it's also a lot cheaper, right? People, like things that are made of like these hardwoods. They're probably like more valuable because they have that prestige
Right.
to it. Right.
Yeah.
So in the temperate zone, you actually see seasons. So in the tropics, right, you don't really have like all 4 seasons like clearly defined. In the temperate zone, you have like the clearly like 4 seasons. So you have seasonal changes are distinct in temperate forests. And they're saying that a lot of them have built adaptations for different seasons. So that's why a lot of the trees here, they lose their leaves during the fall and regrow them in the spring. A lot of animals, they also hibernate in the winter, and they have different methods for surviving the winter. So there's different kinds of things. Some hibernate, Others, so there's like different levels of hibernation, kind of. Like some
Hmm.
levels, they're like, they still get up and they're eating and drinking during the winter, but just not as much. Others, they like completely, they're out
Go to
and
sleep. Yeah.
they completely go to sleep.
For a whole season, brother. Imagine that.
Hmm.
So
Yeah,
chill, brother.
yeah,
The chill life. They just like sleep for a whole
right.
winter.
But then it's also like dangerous sometimes because like sometimes when like bears they get old, right? They say
Uh-huh.
that so the thing is like so they watch the bears. They people like study like how the fat layers of the bears increases during the summer and early fall, and
Uh-huh.
then so sometimes they notice that, oh, this bear when it's starting to get old it's not putting on as much fat,
Uh-huh.
and so when the winter comes they know, oh, this bear is probably may not survive because
Probably gonna
yeah,
die, yeah,
like
because
at
of
this
hunger.
point it should be like a lot bigger and still is still pretty small.
Like it's gonna die from malnutrition, basically.
Right. Yeah. We have deserts, right? So deserts are basically so deserts are not necessarily like warm, right? They could be cold as well. But basically, their
Yeah,
definition,
I heard in the nighttime deserts are really cold.
right? Yeah, yeah. Deserts are very cold. So they receive less than 25 centimeters of water per year, right? So
Yeah.
so they're saying that the most likely location is near the 30-degree latitudes where dry, warm air descends due to convection currents, right?
Hmm.
So there's two things. So we talked about this one on the leeward side of mountain ranges, right? So remember we were talking about
Hmm.
California, right? Like when the air goes over a mountain, on the other
Hmm.
side it's just gonna be dry, right?
Uh-huh.
So that's one reason. Another is that near the 30-degree latitude. So you notice, let's go back up to the thing. So notice at about the 30-degree latitude, right? You notice like it says dry air descends and warms. You see
Hmm.
30 degrees, right? You see the red arrows coming down?
Yeah, yeah, yeah. Why is that happening? I thought warm air ascends, not descends.
Uh, no. So it descends and then it warms. So yeah, so that's what I think. This picture is not the best picture. That's why the other picture that we were looking at. Let me go back to the other picture again. That's what, yeah. I think this picture is not the best. That's why. Let's go back to the other picture. So remember this picture over here,
Yeah,
right?
yeah, yeah.
Right. So I think this. Cause I remember this is the type of picture I've always seen before. So I think let's stick with this picture here. So you see at the 30 degrees, you see the cold air
Mhm.
descending, right?
Wait, brother, which one is the one I'm supposed to look at?
Hmm?
The top one or the? You know what I'm saying? Like there's two.
Yeah. Okay. So
Oh.
this is 0,
Uh,
30, 60,
so
and 90. So 30 is right here.
so 30 is, yeah, the one where the warm air is descending and the cool air is going down.
Right. No. Well, once the warm air cools, and so now you have more cooler air descending.
Wait, brother, exactly. Okay, which one are we looking at? Like the, so I'm saying like, okay, so the one up, so the one directly to your left or like the top left, like
This
to
is
your
right.
pointer.
Right. So you
Just
see.
point. Wait. Just point on which one we're looking at.
Okay.
Like to the center
Let
of
me
which
show
one
you
we're
the thing.
looking at. Which like
Okay.
current we're
Okay.
looking at.
Do you see right here? This is 30. So this right here, where air is descending from both sides.
No,
This is
that's not what I'm saying, brother. Like, yeah, but like which one? There's two over here. So which one are we looking at?
no. You mean two arrows,
Yeah, like no, like
two cells?
two cycles. Yeah, two
Yeah. Oh
cycles.
yeah.
These two cycles.
So in this case, you can see it's coming down in both from both directions. So it's like it's like the center of both of these cycles.
Okay, I see.
Does that make sense, right? Like both of these,
Yeah.
like from both of these cycles, both of them are coming down at this location. So for example, we're not interested in this part of the cycle. So it's not about the cycle. Like
Uh-huh.
it's not, I'm not looking at this whole cycle, for example, right? I'm just
Uh-huh.
looking at 30 degrees north, this right here, right?
Uh-huh.
This going up here is at 60 degrees north. So I'm not worried about that.
Uh-huh.
I'm just looking at 30 degrees. It's coming down. The air is coming down,
Uh-huh.
right? So I'm looking at just this part of both cycles.
Mm.
Right. So they're saying that at that place, 30 degrees, there's like there's a lot of deserts in that area.
Yeah, but like it says warm air goes down
Yeah, right. So you see the air
in this
coming
thing.
down, right?
But it's warm air. Warm air goes up, not down.
No. So at that point, so the air is cold. So when it reaches the ground, then it becomes warm.
So, but look, it says where dry, warm air descends due to convection
Yeah, so
currents.
I think that area, when it reaches the ground, then it's gonna be warm. But I don't think at the
Basically,
very top.
so it's basically dry air until it
Yeah,
just dry air, like dry air, and then until it reaches the ground, and then once it reaches the ground, it starts becoming warm in it.
right.
It's warm, dry air, and it starts going up. Is what you're
Yeah,
saying.
so I think this is the same thing. This was also showing right at 30 degrees, right?
Mm-hmm.
When it starts ascending, it's cold. When it reaches the ground, then it becomes warmer.
Uh huh.
Yeah.
Uh huh.
So I would probably say maybe like dry, cold air. Like when it's ascending, it's cold, but then it heats up when it hits the ground. That's what I would say.
Exactly.
All right. Is this showing up? I don't know if this is showing. Is it showing the PowerPoint?
Yeah, it's showing the PowerPoint.
Okay. All right. So, all right. So this is basically the desert. So you have plants that are called succulents, and they store a lot of water. That's why like a cactus is like big. It's storing a lot of water inside of its tissues. So these are
Uh,
called succulents. Right. A lot of animals they also they stay inside during the day and they come out at night in order
oh,
to
wait.
eat.
So if you're in a desert,
Mhm.
then you can eat cactus for water.
Yeah, so I don't know how I don't know if it's like if you open it up it's just like water
Yeah, it's not
or
like literal water, but like
yeah
you,
yeah it might be like a like if
it,
you look at it
it's like the fluid is inside. So when you eat it, you get like water in your body.
yeah kind of like a like kind of like a jelly kind of thing.
Yeah,
That's what I'm guessing.
but like you still get, if you get it, you still receive water content in your
Yeah,
body.
exactly right. So you receive all the water content.
Yeah, it's like if you eat the eyeball of a fish, brother, it also has water like
Oh yeah.
fluid. So
Oh yeah.
yeah,
So you have the
I'm gonna start
aquatic
eating fish
biomes, right, which is
eyeballs.
basically for water. So you have both the marine and freshwater, right? So
Uh,
all different kinds of things determine, what kind of things live there, right? So you have temperature, sunlight, and salinity. So temperature uh, changes the amount of dissolved gases. So the colder the water is, the more oxygen can dissolve there.
uh,
So that's one reason why they say so. Like salmon, right? Where do salmon live? Do they live in the north, in the cold water, or near the equator?
they live in the fresh water, cold fresh water.
Yeah, so cold fresh water and salt water, right? Basically cold water. So
Oh,
salmon, right? They require like a lot of energy. They're going really fast, right? They're
uh,
going really fast. They require a lot of energy. So that's
uh,
why a lot of those species that require a lot of energy, they swim fast and that kind of thing. They live up in the cold water because they need more oxygen, right? If they're going to be doing a lot more, a lot more work, a lot more swimming, they need more oxygen. They're going to live in the
uh,
cold water, right? So that's why a lot of the fish in the tropics and in the
uh,
warm area, they're not like salmon. They're not like just swimming super fast. They're just like taking their time, going slowly, like tilapia
uh,
and stuff like that,
yeah.
because there's not as much oxygen in the water.
Hmm.
Right. Right. In addition, salinity, right, also determines, right. There are
Salinity is the amount of salt in the water, right? Or like it's
right,
saltiness, right?
right, the amount of salt, right. So
Mm,
some kinds of creatures they can live in the salt water, others in fresh water. Some live only in
mm,
the middle, where it's like where the two are mixing, and then others can
mm.
live all throughout the entire range.
Where did where two mix where like the where river and ocean combine, right?
Right, that's called estuary, right?
What's it called?
Estuary,
Estuary. All right.
right, right.
I didn't
So,
know
so now
that.
another thing that happens here is talking about. It says icing a body of water increases the salinity of the water. So what does that mean? It means if I take like a bottle of salt water, right, and I put it into the freezer, right,
Mm,
so the water starts to turn to ice, right, at the very top, right, like an
yeah.
iceberg. So that ice is taking a lot of the water, but leaving behind all the salt,
Oh, like so its salinity decreases
right? So
as it's
exactly. So in the resulting water, right, you have less water, but the salt has remained the same.
oh,
So it's going to become more salty,
oh, I see.
right? So that's important for like in the polar regions.
Polar regions.
Right.
That's a
Right.
okay. Yeah, I see.
So we have so freshwater lakes and ponds are called lentic ecosystems. So lentic ecosystems are like all these different kinds of examples. You have lakes, bogs, ponds, swamps, and marshes, which are here in South Florida. Obviously, a lot of marshes and that kind of thing.
A lot of marshes and swamps,
Right.
right?
So in the marsh, we have special
Bogs.
kinds of grasses that can live in these like waterlogged kinds of areas. You know, like the sawgrass that they always have here.
Yeah,
So,
yeah, like in
mhm,
what's it called? Everglades. Everglades has a lot of these marshes.
right. So basically, there, as long as it's not too deep, but still,
Uh,
if there's water, if it's completely covered with water, that kind of grass can live
uh,
there, right? So these are different kinds of
yeah.
lentic systems, right?
Uh,
Right. So it's also talking about. So let's suppose you're higher up in the mountains, right? So
uh,
the higher up you are in the mountains, right? Then there's less. The air gets thinner, right?
uh.
So what does that mean that the air gets thinner, the higher up you are in the mountains?
So like there's a less the what's it called? The air pressure, I believe, decreases, right? So there's
Right.
less air.
Right.
That's why it becomes harder to breathe because you're getting closer to the edge of the atmosphere kind of thing, right? Like,
Right. So you
you know
have
what I'm saying?
if you have the so basically like the air particles there are like more spread out, right?
Yeah.
So the
Oh
more
yeah.
spread out
Okay.
they are,
Uh-huh.
then then like there's less chance for oxygen to get into the lake or into the water.
But that doesn't make sense, brother, because like the colder it is, right,
Mhm.
the
Yeah,
less
right,
active the molecules of the air are,
right.
which makes them not be as much spread out. Because air has to be, what I'm saying? Like air is just really active. That's why it gets spreads out so much.
Right.
Like water
Right.
stays barely together, air
Right.
spreads out.
So there's
See?
two factors, right? So that's one factor, that's the temperature, but the other
Uh,
factor is that the farther you are from the Earth's center, the less gravity
uh,
there is,
oh yeah, you're right.
so basically the air is pulled towards sea level. So down here near sea level, the
Uh,
air is much more compact, right?
uh,
As you go farther out, there's gonna be less and less air because
less and less, right?
most of the air molecules have been pulled towards the center. So that force kind of dominates.
Mhm.
So yeah, so that's correct. That's like another. So the thing is, as you see here, it's very complicated, right? There's like multiple factors going on,
Multiple factors, yes.
right? So, but I would say like that's the dominant factor is that because of gravity, the air is pulled here, and so there's less up there.
Uh-huh.
So it says here because lakes are static locations with
Uh-huh.
much smaller volumes than oceans or rivers, temperatures can increase and decrease at faster rates. So lakes are obviously change temperatures, much more quickly than oceans, right?
Uh-huh.
So currents of cooler or warmer waters, like that of an
Uh-huh.
ocean, do not affect lakes unless they are part of a runoff or tributary system. So what does that mean? It means that a smaller kind of stream or river that flows into a larger lake or river,
Mhm.
that's called a tributary. So if the
Yeah.
lake itself has tributaries, then whatever's going on in the tributary is going to influence the lake,
What's going on in the lake?
right?
Yes.
You can have currents and things like that form as a result of the water flowing in.
Uh-huh.
Right. All right. So we have, water, right? So water has what is called a very high specific heat. That means that
I think we did this right before specific heat.
yeah, I think we talked
It's
about
like the amount of
yeah, I think we talked about the bases, right?
heat that it takes for the water to rise 1 degree in
Right.
temperature.
Yeah, I think.
hmm So basically, so water, because of all these properties, it basically also, it basically stratifies. So stratifies means that it forms layers. So in a lake, right, the colder water is more dense, and so it's going to sink to the bottom, and the water at the top is generally going to be warmer, right?
Hmm.
Again, there's like multiple factors. Like for example, let's suppose it's, so I mean, there's like all the different kinds of factors, but this is like one
Yeah.
factor.
I understand. Like if, for example, in the ocean, the sunlight penetrates at the top, so it's hotter than the deep waters where the sunlight doesn't come through, so there's no like heat coming in, right?
Yeah. So that's one reason. Another reason is just that warm water is less dense than
Uh-huh.
cold water. So just like if you put oil on top of water, it forms different layers. Right? Same thing
Uh-huh.
when it comes here, it stratifies. Stratifies means it forms different layers.
Uh-huh.
Right?
Mm.
Temperatures. So let's talk about what are the effects of stratification, right? So stratification and seasonal conditions influence the life cycles of fish, amphibians, water insects, and plants. So during the
Uh-huh.
spring, fish and frogs spawn or release eggs for reproduction. During much of the winter, ice insulates the water underneath, making it possible for fish to survive. So one of the things that they're talking about is that these different kinds of creatures, they're adjusted, and they understand like when is it time to lay eggs, when is a good time for to laying eggs, and when is a good time for them to kind of rest. So
Mm.
some of these creatures, they do what's called estivation. They basically, it's almost kind of like being dormant. They just like lower their body temperature, lower the amount of energy they're using, and kind of conserve their energy for the spring, right?
Mhm.
When there's going to be more food. So another thing is, I forgot what it was. I think there was something else I'm going to mention. Oh yeah. So we know that ice, right? We know that
Mhm.
ice, when it freezes, it becomes less dense, right? So it rises to
Yeah.
the top. So when it does
Mhm.
that, right? Because when most things freeze, they become more dense, right? Because their molecules
Yeah.
get more packed together. So if that was the case, ice would just sink to the bottom.
Uh-huh.
Then what would happen is the next layer would freeze, and it would sink to the bottom. Then the
Uh-huh.
next layer, and the next layer, and pretty soon the whole lake would be frozen, right?
Yeah.
Yeah.
But because ice, does not sink, but actually rises,
Mhm.
once the top freezes, it provides insulation for the bottom, so the bottom can remain as water.
Uh-huh.
Otherwise, all the creatures here would all be dead during
Uh-huh.
the winter, right? Right. So we have, different kinds of coastal ecosystems. So one of the interesting things is that there's something called phytoplankton, right? So phytoplankton, let me see anymore. So phytoplankton are basically tiny microscopic organisms that make their own food, autotrophic organisms. So they actually say that phytoplankton provide more oxygen for the earth than like the trees and plants and stuff like that on land. They're saying that actually phytoplankton produce more oxygen than all the plants and things and trees on land.
Mhm.
Right. So now along the coasts, right, there's a lot of different kinds of organisms and ecosystems that exist along the coast. Like for example, you have certain organisms, they're adjusted to living, they're adjusted to the tides. So when the high tide comes in, right, the water goes in, and then when it leaves, right, when it leaves and the low tide goes out, then what's happened is that you often have pools of water that remain on the beach.
Mhm.
And so there's creatures that are adjusted to living just in these tide pools, right? Now, ocean currents, right? So let's suppose, so we live near the, Gulf Stream, right? So we live near the Gulf Stream. So the Gulf Stream, like where does it go? Does it go from south to north, or from north to south?
I'm not sure.
So it's basically going north. So the water comes from near the equator and is bringing water, like next to Florida as it's going north. So that makes Florida a little bit warmer than it should be. Does that make sense? It makes Florida like a little bit warmer than you would expect at our latitude. On the other side, in California, right, the California current is actually bringing water down from the north, from the Arctic. And so what happens, California, at least near the coast, is going to be slightly cooler than you would expect it to be. Does that make sense? So
Yeah.
the coasts, they're influenced by the ocean currents. If there's warm water being brought from the equator, that area of the land is going to become a little bit warmer. If cold water is coming from the north, that land is going to become a little bit colder.
Mm.
Right? Right. And of course, coastlines are very, very important for fish, shellfish, and seaweed. Right? So a lot of the, if you go to like, especially in the Pacific, along that coast, California, there's like a lot of, there's a lot of, like kelp forests and different things that, different kinds of seaweed forests underneath the ground. Next to Chile, into South America, that area right next to the coast of water, that's like the most productive area, I think, in the world for like fishing and all those kinds of things. So there's like a lot of, people who go fishing there. Seabirds are always there. Like seabirds have learned that this area has like the most amount of fish. So near coasts, there can be like a lot of biodiversity.
Yeah.
All right. So what is an estuary, right? So when we have a river or fresh water, right, the water coming in has low salt. But then when it meets the ocean, right, there's not like a sudden change in the salinity from the fresh water to the salt water. There's an area where there's an area where there's kind of like a mixing zone, right? So we got fresh water coming in here, and the salt water, the ocean is here. In the middle is kind of like a mixing zone. The salinity is kind of like halfway between the fresh water and the salt water, right? So this term is called brackish. Brackish means kind of like halfway in between, right? If you ever heard the term like brackish water, that basically means that it's kind of salty but not too salty. So that's like an estuary. Estuary is like halfway in between fresh water and the salt water of the ocean, right? So estuaries, like for example, all in Florida, there's many estuaries, like throughout where the Everglades meet the ocean, right? Do you know like down like near Florida Bay and those kinds of areas? Right, that's like all that fresh water from the Everglades, right, is going down and mixing with the ocean right there. So there's a lot of creatures that live there, and so there's a lot of creatures that live in the estuary before they become fully grown and go out into the ocean. So estuaries are good places for things like that, right? Another thing is, so estuaries, they usually have like a lot of sediment. So sediment is things like sand and all those kinds of things, right? So so basically the river or the fresh water, usually as it's flowing, right, it's grinding away at the sides of the of whatever wherever it's traveling through, and whatever sand it picks up, it takes with it, and all of a sudden here, right, what happens is that the flow of water suddenly slows down because it's all of a sudden widening out, right? Like if you have water flowing through a thin area, it goes much quicker. Does that make sense? So if the water goes quicker, it picks up sand, it picks stuff up. Here, when it suddenly slows down as it meets the ocean, all of a sudden it lets go of those particles because it doesn't have the speed to carry them anymore. And so all of a sudden, all this silt and sediment and sand and stuff suddenly collects in this area. And so that also brings a lot of nutrients, because all that stuff is a lot of nutrients. And so, all those nutrients, it can be, are useful for, for production of, fish and fish and invertebrates and all those kinds of things, plants and those kinds of things. All right, are you guys still here? All right, I think I just went away for a second. All right, so that's pretty much it for this lesson. Right here is just talking about, okay, in the estuaries there's a lot of fish, shellfish, right, manatee, seagrasses, right? So these are areas where there's like a lot of nutrients. So there's like a lot of organisms that live there, right? And of course the mangrove forest that the mangroves, they live right on the edge. They're adapted to this estuarian kind of environment, right?